Hello and welcome back to geometry. This is section 1.6. It's the last section in the chapter, in chapter 1. So our objective today is going to be to identify and name polygons, different types of polygons, and then find the perimeter, circumference, and area of two-dimensional figures. So let's start with what a polygon is. It's a closed figure formed by segments. So you see the example on the right here. It's formed by a bunch of line segments, GH, HJ, JK, and so on, and vertices. And it's a closed figure. There's no openings where it doesn't connect. There are a couple stipulations of polygons. Number one, the sides with common endpoints are noncollinear. So you see side GH and side GM here. Okay, and they have a common endpoint G, but H and M are noncollinear. They're not on the same line. Okay. The other thing would be, the other stipulation would be that each side intersects only at the endpoints. So GH intersects with JH at point H, but that's the only place that they intersect. They don't intersect anywhere else. It's made up of line segments and vertices. Okay, the symbol and how we name it, it's named by the letters of the vertices in order. So we would call this polygon GHJKLM, just going around the shape in order there. So an example of another polygon, we already have one there. Let's draw another one for you. If we just said, let's make a little pentagon here, okay? If we label this A, B, C, D, E, okay, we would call this pentagon. It's pentagon because it's 5 shapes. We would call it pentagon A, B, C, D, E. Okay? A non-example would be something like, let's say, something like this, where you can see that they don't have vertices. These 2 points right, this line and this line, they don't intersect. They just come and leave this open space here. That's no good, so that would be a non-example. And another non-example would be something like this. And why is that not a polygon? Well, because the only place that they can intersect is in the endpoints, and in this case, this intersection point right here is not at the endpoint. So that would be this stipulation here. It does not intersect at the endpoint, so that is not a polygon. It'd be 2 separate polygons. You have one here and this one here, but that whole thing in general is not a polygon. Okay? All right, so let's move on to a couple descriptions of polygons. Concave and convex. These kind of go together. Okay? Concave and convex. So a concave polygon is a vertex that lies, or has a vertex that lies in the interior of the polygon. So you have an example right here. You can see that this vertex right here lies inside because it kind of indents. So that's a concave polygon, all right? Because it has an indentation. The other one, our second example, would be a convex polygon. No vertices are interior points. You can see in this example, the bottom one, this pentagon here, there's no vertice that lies inside that shape like the first example. So that would be convex. Yeah. So this would be a concave example, and this one down here would be convex. All right. The next would be regular or irregular. So the regular polygon has all sides and angles are congruent. All sides and angles are congruent. That would make that a regular polygon. So if you look at our examples here, this would be a regular convex pentagon because it has all 5 sides are congruent and also all 5 angles are congruent. All right? The example above here, sure, you can see that all sides are congruent by these dash marks, but the angles are not. We've got a single arc and a single arc, so those 2 angles are congruent here, but these 2 down here have double arcs, which means they're congruent to each other, but not these. So this would be a concave, and it would be not regular. You can say not regular or non-regular, or irregular. Okay, but that's the examples there. Perimeter, you probably know a little bit about perimeter. Perimeter is just the sum of the lengths of the sides. So you just add up all the outside edges. Circumference, when dealing with a circle, that's kind of like the perimeter of a circle. It's just the distance around a circle. And then area, we talk about being the number of square units needed to cover a surface. The area would be all the stuff inside the pentagon, number of square units needed to cover a surface. Okay, so let's take a look at some formulas here. Perimeter, circumference, and area. And you've got all down here, you can see we've got all these different letters and what they stand for. So let's do perimeter at the top, and then we'll do area, and this, not at the top. Perimeter will be this first empty box, and area will be the second empty box. So one thing we're going to look at is we'll say that these first three, triangle, square, rectangle, the perimeter, P, is going to be equal to the sum of their sides. So the triangle has 3 sides. You would add all those up to get your perimeter. The square and the rectangle both have 4, so you would just add up all their outside edges to get that. Okay. Another way, when we talk perimeter, like with a circle, would be circumference. That's kind of the perimeter of a circle. So what we would do here is we would say circumference is 2 pi r, 2 times pi times r, which is the radius, or a lot of times people say pi times d, because 2 times the radius is going to give us the diameter anyways, so a lot of times they say circumference is pi times the diameter. All right, for our area formulas. Area. For the triangle, you're going to have a base times a height, and then we're going to divide that by 2. That's your formula, and you can talk about that, how if you could add another triangle next to this one, it would make a rectangle, and that's kind of how the formula got derived. You don't have to know that, just know that it's base times height divided by 2. For the square or the rectangle, it's basically the same, whether it's a square or a rectangle. All squares are rectangles, so the formula would be the same, base times height. Base times height. And then for the circle, a little bit different. For the circle formula would be area equals pi r squared. This time we're squaring the radius and then multiplying by pi. Okay, so those would be your formulas in which we can use to help you out. Okay, and I'm just going to kind of box these in just to say that this is the sum of sides works for all 3 of these. Okay, and then like same thing here, the base times height works for both square and rectangle. Okay, so that's kind of some common formulas in which to find area and perimeter. All right, so let's do some word problems about this. A landscaper designer is putting back a black plastic edging around a rectangular flower bed that has a length of 5.7 and a width of 3.8. So the question here is, find the perimeter of the garden. All right, so let's just draw a little diagram here. That always helps if we make a little diagram of the garden. Let's go ahead, and it's going to be a rectangle. So we know it's rectangular, so let's just draw a little rectangle here. All right, and then one side is a length of 5.7 and a width of 3.8. So we'll put 5.7 here and 3.8 here. Well, because it's a rectangle, we know that this side here is equal to this side, and this side, the 3.8 side, is equal to the opposite side as well because it's a rectangle. So when we find the perimeter, we're just adding all those up. So I've got 5.7 plus 5.7 plus 3.8 plus 3.8, and that'll give me the total perimeter. So you can use your calculator and figure out that that is going to come out to 19 meters. We always label it because it's in meters, so 19 meters would be your perimeter. Okay. The second part of this question says, well, suppose that the length and width are tripled. What's the effect, and what effect does that have on the perimeter? Well, if we did that, Let's triple each of these sides. If we tripled the 5.7, and we, 5.7 times 3 is tripling it, that would give us 17.1, I think. And then 3.8, if we tripled that, would be 11.4, I believe. So we triple those, then find the perimeter. Now we're basically saying perimeter equals 11.4 plus 11.4 plus 17.1 plus 17.1. And what does that equal? If you do the math, you punch it in your calculator, you end up getting 57 meters for that perimeter. So what effect did it have? What's the relationship between 19 and 57? Well, it also tripled it. 19 times 3 is going to give you 57. So what effect did it have on it? The effect was it tripled the perimeter as well. Okay. Alrighty, let's go on to the next one. And this one, we're just kind of like going to go through and label some polygons. And you guys might know these as well. A lot of them you will know. Some of them you might not know. All right, so let's start with 3. We know a 3-sided polygon is called a triangle. A 4-sided polygon, now some of you guys are going to jump right to it and say rectangle or square, but there's also a parallelogram and a rhombus, a kite. There's all sorts of them. So we give the 4-sided are quadrilaterals. Quadrilaterals, they're a whole section 4-sided. 5, we talked about that earlier, is a pentagon. Pentagon. 6, a lot of you guys might know a 6-sided object is a hexagon. Okay. 7 is a tricky one. Not a lot of people know 7. 7 is a heptagon. A heptagon. An 8-sided object is an octagon. That's one that a lot of us know about, an octagon. And a 9-sided object is a nonagon. Nonagon. Some people know that one, other people don't. 10 is called a decagon. Decagon. An 11-sided object is called a hendecagon. And finally, the 12 is we're going to go on. It's called it's similar to decagon. It's a dodecagon. Okay, and then if we get down anything else like n, these are the top 12 that you're going to see, or up to 12 sizes. These are the most common ones that you're going to see. And then once you get certain to points where you get to an n, we just call it an n-gon. So we don't need a name for a 57-sided polygon. We would just call it a 57-gon. Okay. So here's number 2 example. It says name each polygon by its number of sides, then classify it as convex, concave, regular, or irregular. So we can just tell right away by the number of sides, 1, 2, 3, 4, 5, 6, that it's a hexagon. And then let's say, is it convex or concave? Well, it doesn't have any points in the interior, so it would be convex. And in regular or irregular, you would actually have to measure this out. And just for the sake of doing it, what I'm going to do is I'm going to draw in these dash marks here to say all sides are equal. And then we're going to say that all angles are equal as well. So we would say that it is a regular. Okay, how about the bottom one, letter B? How many sides does this have? Well, don't forget to count these vertical ones too. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So a 12-sided would be a dodecagon. And then is this one convex or concave? It has these indentation points here. So that would be a concave polygon, because there's points in the interior. And then we're going to say it's not regular just by the fact that this side here, I know, is different from that side there. So we would say it is irregular. non-regular or not regular. You can say either thing there. Okay? Simple as that. Okay, some word problems now and finding area and perimeter. So use those area and perimeter formulas that we gave you earlier. And there's a couple different steps to solving these. So the first thing you're going to do is you're going to draw this triangle or draw the graph on the graph paper here using the given points. The second thing you're going to do then is you're going to find the lengths of each side. And finding those lengths, you can use distance formula or Pythagorean theorem to do that. Remember, if I'm just going to graph these real quick. Negative 1, 3 puts me right here. Negative 3, 1. Negative 3, negative 1 puts me here. And then 4, negative 1 puts me here. Okay, so my triangle looks like this. So work smarter, not harder. Right now, I can tell you that this has a distance of 1, 2, 3, 4, 5, 6, 7. For the base there, has a distance of 7. And then you can use you're going to have to use for this side here and this side, because they're diagonal, you can't count them. So you're going to have to use the distance formula or Pythagorean theorem to find those distances to get your perimeter. And then finally, you're going to use the formulas to find perimeter and area. One tip I'll give you is for perimeter, yes, you're going to have to find all three edges, but since it's a triangle, for area, you already have your base of 7. Use this as your height, straight up and down. You can just count that, and that'll give you your value for the area. So make sure we do both, area and perimeter, and you guys can work on that. And the last one, too, I'm going to give you guys on your own as well. The width of a rectangle is 5 less than twice its length. The perimeter is 80 centimeters, so find the length of each side. My tip here is that your width is going to be 5 less than twice the length. So twice the length would be 2 times L, and then 5 less is going to be minus 5. So when you put this into an equation, you're going to say W plus 2L minus 5. But you have to do that again, right? You're going to have another W, and you're going to have another 2L minus 5, because it's a rectangle, equals your perimeter of 80. Now you can combine like terms and solve from there. I'll let you guys work on that one. Okay? All right, that's it for 1/6 polygons. A little longer than usual, but there was a lot of information to it. So if you have any questions, please bring them with you, and we will continue to work on this. Thanks a bunch, and we'll see you next time.